So we're at this point where AI agents can actually do real work for us. But with all that power comes a huge and, honestly, a kind of terrifying engineering problem.
Right. This is the question that keeps developers up at night. You want your agent to be useful, to actually interact with the world, but you can't risk it going wild, leaking your data, or just breaking all your systems. The real challenge is building a leash that's strong enough.
Well, the architecture we're looking at today, NVIDIA's NemoClaw, has this absolutely brilliant metaphor for this problem. The AI agent, which is called OpenClaw, is the all-powerful genie. It can grant your wishes, do all the cool stuff. But it lives inside the lamp, and that's NVIDIA's OpenShell, a secure sandbox that strictly defines the rules of the magic. So yeah, the genie has the power, but the lamp has all the control.
And that control is built in layers, like a Russian doll. As you can see here, you go from your host operating system, through Docker, through Kubernetes, all the way down to the agent and the model, sitting right there at the very core. Each one of these layers provides another critical boundary, another layer of isolation.
So, how does this lamp actually bind the genie? Well, it's not just one thing, it's four distinct, enforceable security contracts. Let's break them down.
First up, execution. It uses this really powerful Linux feature called Landlock, which means the agent is forbidden from touching your host files. And this isn't just a suggestion, it's the kernel itself saying, nope, not happening. Second, network. Every single outbound connection gets intercepted, and the default policy is super simple, deny all. Third, credential. The agent never, ever sees your real API keys. We'll talk more on that in just a second. And finally, audit. Every single action is logged, and there's a master kill switch to shut it all down instantly.
Now, this credential binding, this is the cleverest part of the whole setup. The agent's environment variables, they don't actually have your real tokens, like your Slack API key. Instead, they just hold a placeholder, a marker. So when the agent makes an API call, a proxy sitting in the lamp sees that placeholder, looks up the real secret from its own secure storage, and swaps it in right at the last millisecond before the request leaves your machine. So what happens if a prompt injection attack dumps the agent's environment? Well, it just gets back useless placeholders, not your keys. It's brilliant.
But look, no architecture is perfect, right? It's all still code written by humans. While trying to get a Slack bot to work, the author of this analysis ran into a really strange error. And this is where the story gets pretty interesting.
The error was invalid auth from Slack, but here's the thing, the tokens were correct. So, after diving deep into the NemoClaw source code, the author found it, a tiny bug in the configuration script. Turns out, Slack socket mode needs two different tokens to work, but the script was only providing one. It was just quietly dropping a required field, which caused the whole thing to fail.
And here's the crucial point. The fix was a single line of code. Because the entire architecture is open source, the user could find the root cause, patch it themselves, and file a really detailed bug report. That's a level of transparency and control you just don't get with a closed-off, proprietary hosted agent. This is the superpower of open systems, applied directly to AI safety.
Okay, so we've got a secure, auditable, and even fixable lamp. So what? What does that actually let us do? How does this level of safety unlock new capabilities?
This slide illustrates a really critical mental shift. The naive approach, the wrong way, is to just mount your files directly into the agent's container. That basically bypasses all the protections we just talked about. The right way is to run a separate service, like a RAG database, outside the lamp. The agent can only query the service through a protected API. It asks the question, the service provides a grounded answer. The agent never ever gets to touch the raw files. And with that pattern, the possibilities are just incredible. You could have a private home bot that looks up appliance manuals without it ever reading the files directly, or a domain expert for your personal knowledge base, a private research assistant that can cite sources from your documents. It could even control your smart home, not with broad, scary access, but by making specific audited API calls to your Home Assistant instance, just like it calls the Slack API. So we end on this core idea. For years, we've thought of security as a constraint, right? A set of limitations. But in the world of AI agents, this kind of robust, multi-layered containment is actually the complete opposite. It's an enabler. It's the very thing that gives us the confidence to hand these powerful tools the keys to do real work. Containment is capability. The lamp is the feature.